All right, here we go. We're going to do some review stats problems. So first up, part A, what's the probability that your vehicle is a crossover? So we'll say probability of crossover. And it turns out the sum of all of these should be 1. So we'll just go 1 minus everything else. Right? So you just list them all off with some subtractions. And then I believe it turns out to be 0.24. Yeah. So we'll put a 0.24 right here, and now they all add up to 1. Perfect. All right, second part, part B, find the probability that the vehicle is not an SUV or a minivan. Okay, so not an SUV and not a minivan. So we'll just go 0.46 plus 0.15 plus 0.24. And that should be a 0.85. All right, you'll notice sometimes I put the 0 in front, sometimes I don't. It really doesn't matter. It's probably better to do the 0 out in front, just because if you go 85 and there's supposed to be a point there, but the point is so small you can't tell. It looks like a whole 85, but nobody writes the number 85 with a 0 in front. So that's kind of what's going on there. All right, so third part. This is the trickier one. Given that the vehicle is not a passenger car, so I hear a given. I'm hearing passenger complement, right? So given that the vehicle is not a passenger car, what's the probability that it's a pickup truck? So I'll just go pickup truck over here. All right, so we're going to narrow it down. In fact, let me undo some of this work that I did over here. We do need that 0.24 there. All right, so given that it's not a passenger car, so we're going to get rid of this guy. Now we're looking at out of all of this. So our denominator is whatever all that adds up to. So I'm just going to write it out here. A 0.15 plus a 0.10 plus 0.24 plus 0.05. And then we're looking for minivan. No, just kidding. Let me undo that. We're not looking for minivan. We're looking for truck, pickup truck, which is a 0.15. All right, and resist the temptation to cancel these 0.15s over here. Instead, we're going to get 0.15 over. You add those all up. You should have a 0.54 on the bottom. And I believe that turns out to be about 0.2778. So there you go. So keep in mind when they say given that, not a passenger car, you're narrowing things down. It's no longer out of the whole probability of 1. It's narrowed it down to only these 4. All right, so let's go ahead and move on to number 5. All right, next up. We've got a two-way table, and we do not have totals, so the first thing you'd want to do is go put some totals in. So there you go, and then totals over here, totals over there. So let's see, that's 27 plus 25, 52, 48. I think that's 68. Add those up. It should be a grand total of 120. All right, looking good. So now we need to find the probability that the person drives an SUV. So probability of SUV, you're basically looking at this column here, which is 39 out of 120. And that would be it for A. Next up, part B. So find the probability that the person drives a sedan or exercises. All right. So that means, here, let me get rid of this one. That means we're looking for sedan, which is here, or we'll go with a different color. How about some green? And we'll go or exercises, which is the yes row. So we do have a formula for this. So I'm going to go ahead and write out the formula. It's going to be probability of sedan plus probability of exercise minus the probability of both, which is, I'll just put S and E, okay, because I'm running out of space over there. All right, so we're just going to go use our formula. And if you're confused right now, think of this as A union B. This is A, this is B, this is A and B. You got our main formula, our main general addition formula that works really great here. All right, so the probability of sedan, that was the blue one here. So that would be 45 out of the 120. Next, we got probability of exercise. I'll switch over to the green for that one. That would be 52 out of the 120. And then the overlap, that would be this guy right here, the 25. That 25 was counted twice. So what we're going to do is subtract that one out. All right, and then we should, let's see, that's 97 minus 25. I believe that is 72 out of 120. Let me just double check in the calculator. I believe it's a 0.6 if I remember correctly. 72 divided by 120. Yes, it is 0.6. All right, there you have it. And if you wanted to reduce the fraction, you could do that. That's also 3/5. Okay, very good. So that's it for B. Let's go on to C. Find the probability that the person does not drive a truck. So we'll say truck complement, given that he or she exercises. So we'll say given that they exercise. I guess technically you could put yes there because that's what they say in the table. All right, so find the probability, just double checking that the person does not drive a truck complement, given that he or he exercises for at least 30 minutes a week. Okay, so again, we're going to go back to our table. Let me get rid of some of this mess. Given that they exercise, so we're going to focus on that. Given that they exercise, stay here. In fact, I'm just going to get rid of all of this. Don't even pay attention to it. Just don't. All right, so now I'm looking at the grand total is 52 there for that row. So knowing that they exercise, there's only 52 people that exercise, says so right here. And we want to make sure we're looking for not the truck, so cancel that one out, and there are 2 guys left. So it'll be 25 plus 15, or we could just say 40 out of 52. All right, and that turns into 0.769. All right, there you have it. Okay, moving on to the next question is number R57. Does the new hire use drugs? So let's see here. Many employers require prospective employees to take a drug test. A positive result on this test suggests that the prospective employee uses illegal drugs. However, not all people who test positive use illegal drugs. The test result could be a false positive. A negative test result could be a false negative if the person really does use illegal drugs. In other words, the test came back negative, and that's false because they really did use the illegal drugs. All right, so suppose that 4% of prospective employees use drugs. Well, we can start with that. So let's go like this. And we'll say drugs, no drugs. And we know the percentage of people that, or employees that use drugs. And this is prospective, so these people that want to get the job. So 4% use drugs, and then the other 96%, those should always add up to 1. Do not. Okay, next, that the drug test has a false positive rate of 5%. This is where it gets a little confusing for students because they want to write the words false positive up here. But really, we just want to put positive test and then negative test. And we'll do it again here, positive test, negative test. So now let's talk about a false positive versus a false negative. They said, let's see here. The drug test has a false positive rate of 5%. Okay, let me switch colors on this one. How about some magenta here? So false positive rate of 5%. That means they tested positive, but it's false because they do not use drugs. I'll say that again. It's a positive, but it's false because they do not use drugs. So you have to go down the no drugs tree branch first. Now we're going to put a positive test result of 0.05 there, which means the complement of that would be the negative testing, that would be 95%. So that's a false positive right here. In fact, here you can put the false positive. Again, this is saying that it was a positive test result. It looks like they were doing drugs, but it turns out they were not. It was false. They were not doing drugs. Okay, on the flip side, let's go up to the top side here. It says a false negative of 10%. So that means they have a 10% chance of coming back with a negative, but that's false because even though it said negative, those people, those prospective employees, did use drugs. And then its complement would go up here, so that would be a 0.90. Okay, so you have your false negatives here, and you have your false positives over here. All right, so now it's time to go answer some questions. So part A is done. Draw a tree diagram to model this random process. Next up, we have part B. It says find the probability that the drug test is positive. So probability of positive. Well, there are two different ways to get a positive result. Here's a positive, and it came from this pathway. Here's another positive, and it came from this pathway. We need both of those. We need both of those. And that means we're going to go take the 0.04 times the 0.90 plus the 0.96 times the 0.05. All right, and we're just going to work that out. Let me just double check my numbers here. That's a 90 right here. And that looks good. So that's going to turn out to 0.084. Okay, so it's actually a pretty small percentage. It's only 8% chance of getting a positive test result. All right, so moving on to part C. So next up, if the prospective employee's drug test, let me change those words, given that the prospective employee's drug test result is positive, let me go like this. So given that positive, there we go, given that positive, find the probability that she or he uses illegal drugs. And we'll just say drugs for short. Okay, so we have formulas for this, and it goes like this. If that's your A and that's your B, A given B turns into A and B, so we'll say drugs and positive test, divided by, so this is A and B, divided by the probability of, well, it should be B that would cancel, so that would be a B down here, which means probability of a positive test result. Okay, so now it's time to put this all together. Drugs and positive. Let me do a little different highlighter action here. So probability of drugs and positive, well, we already talked about that one. It was up here. So that's going to be a 0.04 times the 0.90. And then the probability of positive, well, we already calculated that. That's 0.084. All right, we take that, put it all together, we get 0.429. So we got roughly a 43% chance of randomly choosing somebody who does drugs, given that they had a positive test result. All right, that's it for that. All right, we've got a couple of multiple choice questions here. And I think I have enough time to do this first one here. First thing we need to do is get some totals, right? So 28, 32, let's see, that's 60 plus 20 more. We're looking at 80. That's 35, that's 45, so it should be 125 here. And then this should be a 45. That looks like a 50. And that's a 30. And just double checking all of that. So that would be 80 plus 45 is 125. So there's your totals. Always got to get those. Always, always, always. All right, so next, what's the probability that the person owns a Dodge or has a four-wheel drive? Okay, so there's a couple ways to go about that. So it's probability of Dodge or four-wheel drive. Well, that means probability of Dodge plus probability of four-wheel drive minus the probability of both. So I'm going to abbreviate a little bit there. So probability of Dodge, let's see, that would be the 30 here out of the 125. So we're going this way. In fact, let me use a different color for that. How about some highlighter there? So we got some yellow. And then we'll go blue the other direction. So probability of four-wheel, that would be yes, that would be these guys. So that would be 80 out of the 125. But there's some overlap in there. So we're going to have to subtract out this guy right here. That's Dodge and four-wheel drive. So minus out the 20 over 125. And we end up with, what is that, 61? It looks like 90 over 125. So the answer to that would be D. All right, so that's one way to do it. There is another way, though. Another thing you could do, let me go ahead and erase this and this and this and that. Oops, I need the 0 there. So real quickly, let's see. If you really just want Dodge or four-wheel, so just go like this. Dodge, yep, that's a Dodge. Yep, that's a Dodge. Four-wheel, that's a four-wheel. That's a four-wheel. Add those guys up. You're still going to get 90, right? Put those together, you still got 90. All right, that's it. We'll see you next time.